In this video, I'll give you some tips for solving the ALEKS problem called writing a chemical equation from a description of the reaction. There's only one version of this problem, but there are a lot of variations of this particular problem. Some problems give you only names of the molecules involved in the chemical equation. Some problems will give you the molecular formulas of some or all. All of the problems are giving us the states of everything in the equation, so that's at least helpful. And then there are different ways that ALEKS gives you hints about which molecules are reactants and which molecules are products. And I think that's probably the thing that I'd like to start with. When you see the phrase reacts with, that usually means that these two substances are both the reactant. So my nitrogen gas and my hydrogen gas are the reactants. And instead of thinking about reacts with, I'm just going to think about the plus symbol like we would normally use in a chemical equation. There's going to be a variety of different terms that ALEKS uses to indicate where the reaction arrow goes. In this one, it's saying it's forming something, but it could be a little bit more descriptive, like it could be saying that it decomposes. It could be describing a particular type of chemical reaction. It could say something like it produces, but you should be able, if you're reading carefully, you should be able to find that clue that gives you a hint about where the reaction arrow belongs. And so everything on the other side, everything following that reaction arrow, this is going to be my products. So I have two reactants in this equation, nitrogen gas and hydrogen gas, and I have one product, ammonia gas. And then the second challenge I have in this problem is that I need to figure out what the formulas are for each one of these different substances because ALEKS is not providing it to me. So for most elements, nitrogen and hydrogen are elements. Most elements exist as just a single atom. So for example, like lithium, it just exists as a single lithium atom. But there are a few elements that exist as diatomic molecules. That means two of the atoms combined together. And I'm going to give you a list of these because it's going to be really helpful for this problem. So hydrogen, which is one, nitrogen, which is one that we have in this problem, fluorine, oxygen, iodine, chlorine, and bromine. All of these molecules exist as diatomic molecules. So if it says in a problem nitrogen gas, you're going to interpret that as the N2 molecule. If it says hydrogen gas, you're going to interpret that as the H2 molecule. If it says bromine, you're going to interpret that as the Br2 molecule. And there isn't anything in this problem that's giving you this hint, so that's why I'm giving it to you over here. So I know that I have nitrogen gas. I'm going to write that as N2, and ALEKS does want you to include the states. And it is reacting with hydrogen gas, H2, and I'm going to include that state as well. And it is producing ammonia gas. Now here is one, maybe you have the formula for ammonia memorized, but probably not. And that's okay if you don't, because you can just access the internet and look up the formula for ammonia gas. So I could just type in the formula for ammonia. Don't get it confused with ammonium, and this is telling me that it is NH3. And feel free to do that. That's not, there's nothing wrong with needing to look these up. Help you get the problem correct, because there isn't anything in that name, ammonia, that specifically tells you how many nitrogens, how many hydrogens. It doesn't even give you a hint about which atoms are present in the molecule. So like I said, feel free to look that up. Now, once you get all of the molecules in place, the next thing that ALEKS wants you to do is balance this chemical equation. When I'm balancing chemical equations, I like to make a list of all of the atoms that I have on either side of the equation, the reactant side and the product side. I have nitrogen and hydrogen here. I'm starting initially with 2 nitrogen atoms and 2 hydrogen atoms on the left side. And on the right side, I'm starting with 1 nitrogen and 3 hydrogen. And as you probably know, this equation is balanced when I have the same number of atoms on either side of on each side of the equation. So currently right now, I have 2 nitrogen atoms on the left, but only 1 nitrogen atom on the right. To change the quantity of atoms in any molecule, I'm going to do that by modifying the stoichiometric coefficient in front of the molecule. So what I'm not allowed to do is insert a new subscript here, and that would change the formula of the molecule. Remember, when we looked up ammonia, the internet said it was NH3, and that means I'm not allowed to modify that formula to give me more nitrogen atoms. But what I am allowed to do is change the implied 1 stoichiometric coefficient, change that from a 1 to a 2. Now, when I change the stoichiometric coefficient to 2, this tells me that I have 2 NH3 molecules, which means I have a total of 2 nitrogen atoms and I have a total of 6 hydrogen atoms. Because each molecule contains 3 hydrogen atoms, I have 2 molecules at this point. I've got a total of 6 hydrogen. So my nitrogen is now balanced with 2 and 2 on each side. My hydrogen, I have 2 on the left side and I have 6 on the right hand side, which means I need more hydrogen on the left. And again, I'm going to do that by modifying the stoichiometric coefficient in front of the hydrogen. Instead of 1 H2 molecule, I want 3 H2 molecules. Each one contains 2 hydrogen atoms. 3 times 2 gives me a total of 6 hydrogen on the left. And now all of my atoms are balanced.